Okay, today we're going to talk about communication with Merlin 3 LS laser software. Basically there's two types. There's command-based, where you send and receive information, and there's a second type, which is Ethernet IP, which is a more register-based, and we're not going to cover that today. Today we're going to cover the RS-232 and the Ethernet TCP/IP. There's two types of protocols, and if we can take a look at the screen here, I'll explain the difference. First I'm going to go over here to setup, and you see it says host. And right now we have the TCP/IP interface. The other option is RS-232, which is the COM. The difference is one is hardwired, old style RS-232. The other is the TCP/IP, which uses the Ethernet. Once you get beyond that point, they're pretty much the same. There's two types of protocols for either one. There's extended or there's programmable. The difference is the extended protocol, you send data and you get an active response that confirms receipt of the data and gives you some other information. With programmable, it's just send it one way and you hope it gets there. Now, generally we recommend using extended because of the information that's coming back. Programmable protocol is very good if you're sending information from, say, a barcode scanner or an RFID tag, because programmable does let you do some things like take the entire data string and pull a piece out of it. Today we're going to discuss as if you were communicating to this with your PLC. And today we're going to use extended protocol. And with extended protocol, you can see there's a number of tabs here. The port tab, this is used with the RS-232 to tell it the COM number, the baud rate, and this other information. For the Ethernet, the TCP/IP, we give it a socket number, and then we have to give the IP address of the, in this case it would be your PLC. The other tabs here, programmable, this lets you set up some information about the programmable protocol. We're not really going to talk about that today. The maintenance tab lets you create a log file that will log all the data being passed, and you can give that a name and tell it where to save it. Well, for right now, we're going to use the TCP/IP and extended protocol. Right now, you can see we have loaded a pattern. This name's Lex, and you see there's a barcode on it. That's something we were just marking. What I'm going to do here is you can look at this screen. This is a program that we have that's called the server simulator, and this simulates your PLC. And since we're using extended protocol, I'm going to go down here and I'm going to send this a message type P, which means pattern, and I'm going to tell it to load our COM demo. Of course, it would help if I put this in the right place. And if I could spell for some reason, and then if you will look at this screen, when I send this, you'll see that it now loaded the pattern named COM, and it has a couple of lines in there. The first line is text only. The second line contains a variable, and what I'm going to do is I'm going to open these up and show you what they look like. The text has in fact only text. The variable text, you see, it doesn't have text in here. It's got a command that says you're going to expect a 5-character variable. And what's good about this is that you can have plain text in with it, which I'll show you in just a minute. So what I'm going to do, I'm going to go over here and I'm going to tell this, I'm going to send it message type 1, which is plain text. And then I'm going to tell it the line number where I want it. And then I'm going to put in what I'm going to send. And the extended protocol in this case is very similar to your PLC, where it actually sends a number of control characters before it sends the text. The first thing it will send is something that's called start of header. This tells the receiving piece of equipment that a message is coming in. The next thing is going to be the message type. And there's a lot of different message types. One is text, V is variable, and we saw P is pattern. Then it will send a start of text character, which tells the receiving unit that the text or data is the next thing that's going to come. And that would be the line number and whatever the data is. And then it follows that with an end of text character that says this is the end of the data, and a carriage return that basically says this is the end of the message. So I'm going to send this to line 1, and you will notice that I have now sent text to line 1. Now for the second line, I'm going to tell it it's message type V for variable. I'm going to tell it the line number, and then I'm going to send it the information, and you will see that it received text. Now if you look over here, right here it's going to tell you what it received. The little dark lines are non-printable characters. This would be the start of header, the start of text, and some other things that don't really show up. And there's also a character that's either ACK or NACK, which means acknowledged or not acknowledged. And then it's going to tell me the message type, which is V, and the ASCII equivalent of the message type, which is in this case 86. Now John wants me to show you the data scope, which is something that's available in the maintenance tab of the whole stuff. And basically what this does is I'm going to just send this, and I'm going to send line 2. And you will see, now this says received at 5:52. I guess it's later than I thought. Actually, the clock on the computer is wrong. Start of header, message type, which is V, start of text, line number, the actual text, the end of text, and the carriage return. These show up like this because these are, in this case, it's ASCII number 1, ASCII number 2, and those are non-printable characters, so it just shows the start of header as a representation of that. Then it tells me that it's sent back at the same time, start of header, the variable, acknowledge, which means yes, we did receive it okay, start of text and end of text, it's not really sending any text back, the ASCII equivalent of this V, and the carriage return, which is the terminator.